is energy. Energy makes things move, it stops things, and energy is what's necessary to do what we call do work. Okay, so move something across a room, lift your legs, roll your eyes, anything that is going to stop or start something is going to require energy. The example that you see here in the picture is water flowing over a dam. Okay, this is a concept that we're going to talk about in this section, where if the water is up here, it has potential energy. If it falls, okay, it's releasing the energy that becomes kinetic energy, and those are the two major types of energy. So work is done when you climb, when you lift things, when you ride a bicycle, anything like exercises, your heart pumping, and so we look at potential versus kinetic energy, because if you raise something up, you're increasing its potential energy. When it falls back down, it's converted into kinetic energy because then it's doing work. So when it's doing the work, it's called kinetic energy. So we think of potential energy as energy that is being stored, or you're holding it in reserve. It's got the potential to do something. So the water we saw behind the dam, if you compress a spring and then let go of it, right? If you compress it, that's potential, but if you let go of it, it's going to release that energy that you're storing in there. We can also store energy in chemical bonds. So like the reason that we have energy value, or BTUs, in wood and coal and gasoline and things like that, is because we can actually store that energy, put potential energy in the chemical bonds that are holding those things together. And when we release those, then we release energy. And a lot of times energy is released in the form of heat, in the case of coal and wood that we are heating our house. Kinetic energy is energy in motion, and this is when you're using the energy. This is where the water actually flows over the dam. This is where you're running. This is where you're actually burning the wood or the gasoline, or you're swimming or working out. So you've heard what the definition of and the difference is between potential and kinetic energy. So see if you can figure out which of these would be potential or which would be kinetic energy. Okay, how did you do? Rollerblading, obviously you're using energy, so it's kinetic. Peanut butter and jelly sandwich, well, it's potential until you eat it and convert it to energy. Mowing the lawn obviously takes energy, so that's kinetic. The gasoline in the gas tank is really potential energy until you burn it, and then it releases energy as kinetic energy. Heat's measured in units called joules or calories. Notice calorie here has a lowercase c. The SI unit of energy is the joule, capital J, but a calorie is what we use a lot, and a calorie is the amount of energy that it takes to raise the temperature of a gram of water 1 degrees Celsius. Your conversions for these energy measurements: 4.184 joules is equal to 1 calorie. 1 kilojoule, you remember kilo equals 1,000, so 1 kilojoule is 1,000 joules, and 1 kilocalorie is equal to 1,000 calories. Notice that those abbreviations for those units. If you just want to look and kind of compare the differences in energy values, the energy used to sleep is 10 to the 5th joules. Okay, energy from a gallon of gasoline, 10 to the 8 joules, and we go all the way up here to the energy coming from the sun, which is one of the largest values we know of, 10 to the 26 power. So that's a huge amount of energy that we get from the sun. Too bad we can't capture that better. So How many calories are obtained from a pat of butter if it provides 150 joules of energy? So remember, to work these problems, what we're going to do is first we're going to see, okay, what are we given? And we're given what? 150 joules of energy. So that's what we would start with. And we want to get to calories. And I've given you the information that you need to do that, okay, because you know that there are 4.184 joules in 1 calorie. So if you use your dimensional analysis, you should be able to work this problem. So put me on hold, see if you can work it. It's a simple conversion, and then come back and we'll see how you did. All right. How many calories are obtained from a pat of butter if it has 150 joules? Remember from the rules that you state you're given. We said we're given 150 joules. Where we're going is calories. So we go from joules to calories. We know a conversion factor for that. We know 1 calorie equals 4.184 joules. So we set up the problem, start with what you've got, and put the unit that you're going to. So 150 joules times, you always put the unit underneath the next equality to be the same as the one that was before it, so joules and joules. And so we know 1 calorie is the same as 4.184 joules. And so when we multiply that, we have 150 times 1 divided by 4.184. That gives us 36 calories. So answer B was correct. That's the end of Unit 2.3. So you can keep going with me to 2.4, or you can stop and take a break. That's the beauty of this. You can put me on hold.